Okay, in this video, I'll be talking about binary search trees. So, binary search tree is a data structure that's good for storing things in a tree that has a right and left node, sometimes called child. And the benefit of it is a lot of the searching functionalities is on the order complexity of O of n log 2 of n. So it's usually pretty fast for searching, and that's why people tend to use it. So there's typically a lot of different ways of traversing a tree. You have like a pre-order, in order, you have a post-order, and level order. We're just gonna go over the in order method in this video. But to do the other ones, it's pretty simple. You just switch some of the order of some of the calls inside the um, search function that we'll implement in a bit. So let's start off by making a class node. So inside our class node, we need to have our init function, and we're going to pass in a value, and we're going to store that value to value, and we're going to initialize the left and right node to be none. Okay, so that's our node class, and then our main class, we're going to call it the binary search tree, and we're going to create our constructor here, init, and then we're going to have a self dot left. We're going to actually no, that's for the node. We're gonna add a root. So we're gonna have a self dot root equals none. So we're gonna initialize our root to be pointing to nothing. And that's all you need for the constructor. And then we'll start with our insert function. So one thing to note about binary search trees is that the items in there are ordered. So when we insert it, we're gonna have to order it by comparing the values. So we're gonna have a def insert here, self value. And first thing we want to do is check the root to see if it's empty. If it's empty, we will create a new node and point to it. So if self.root equals none, then we're gonna do self.root equals node and pass in the value and just return. Okay. So after you do that, assuming that it's not none, then it's going to pass that if statement. Then we want to set our current node pointer to point to our root node, and then loop through infinitely until the loop breaks, depending on our conditions in there. Okay, so inside, what we want to do is check for the values. So if the value equals the current value, we want to take some action. So we want to return if that's the case because that item already exists, therefore we don't want to do anything, so we return. Otherwise, we're going to do some other checks about the value. So if the value is less than the current value, we want to see if it's going to be empty. So if cur.left is not equal to none, so if it's not equal to none, we want to keep pointing to the current node's left child and kind of keep repeating that. So we're going to say cur equals to cur.left. Otherwise, if we finally reach the end, what we want to do is cur.left and set node to value. Okay. And we're going to return. Now that's for the case of value is less than cur value. What if value is greater than cur value? So that's where the elif comes in. So value is greater than cur value, cur dot value. So we want to say if cur dot right is not equal to none, then we're going to say cur equals cur dot right. Okay, so what this says is if it's not empty, keep traversing down to the right branch and then just keep going down. And otherwise, else, we're going to have cur dot right. This is going to be equal to our new node, and then we're going to pass in the value to create that node. Okay, and then once we do that, we return. So this should implement our insertion function. But before we insert it, let's create a print function so we could actually check our content. So we're gonna have a in order print function, and we'll pass in self, and we will also pass in our current node. So that logic in here, we're gonna use recursion. So if cur node is none, we're gonna return, which means that we are done traversing. Otherwise, we're gonna do self.inOrder print, pass in cur node dot left, and we're gonna print our cur node dot value, and then after that, we're gonna go on the right side. So self dot in order print, and then cur node dot right. Okay. So now let's try making a tree. We're gonna have if name equals main. That's our main test function, and then I'm gonna have a tree called my tree. Create a binary search tree, and then start inserting some things. So I'm gonna insert Kevin, for example, and let's have a print function, my tree dot in order print. And because I need to pass in my root node, I'm gonna say my tree dot root. And if I run this, let me move this to the right. Okay, so if I run this, you can see it prints out Kevin, right? Now let's say we added some more items. Let's say this is Amy, for example, and then maybe this is some guy called Yellow. And if I run this, you can see Amy, Kevin, Yellow. So it's printing out in order as we expect. And we can also implement some other functions like find to see if a certain item exists in a tree. So we're going to do a def find and pass in self, value, and the cur node. So inside our find function, the idea is we want to check if our value equals that value. If it's less than, go on the left side. If it's greater than, go on the right side, and keep repeating that. So we're gonna have if cur node is empty, none, then just return false. Because this function will just return true or false depending on if the item is in the tree. So we're gonna say if value equals the cur node dot value, we will return true because the value exists, right? And then have if value is less than cur node dot value. If the value is less than that, what we want to do is recursively call our self find function, or our find function by using the self because it's part of the class, and then pass in value cur node dot left, and then we want to have a final case for the right side. We want to return something similar, but it's going to be right. So find value cur node dot right. So we could test this out by having some print functions. So I can print my tree dot find, for example, and then maybe we want to find John. And I'm going to pass in my tree dot root. So if I run this, you can see that it prints out false because John is not in there. And if I put Kevin, for example, and run this, you see it's true because Kevin is in the tree. Okay, so that's how you implement a find function. And then let's just implement two more if we want to find a max or min function inside our tree. So we're going to call it def find min self cur node. And again, we're going to call it recursively. So first off, we want to check if cur node is empty. If the node is empty, we want to return none. Okay. Otherwise, we want to loop through all our nodes, do cur node dot left. We want to search on left side because we're looking for a minimum. So if it's not empty, need exclamation mark. If it's not empty, you want to do cur node equals cur node dot left, which means just keep pointing to the left side of the tree. And then finally, when you reach the end, you're gonna return cur node dot value. Okay, so I could test this out by having a print. I'm gonna say min, and then my tree dot find min, and need to pass in cur node, which will be my tree dot root. So if I print this out, let's clear this and run again. You see it prints out Amy because Amy is the smallest. Okay. And I could do a find max function that will be very similar to this. Just gonna copy and paste. So here I'm gonna change this to max. And then here instead of the right, instead of the left, it's gonna be a right. And if I run this, repeat this function call, change this to max, and change this to max here. And if I run this, save it, run it, let's clear this so you can see better. So you can see if I run it, it says YOLO, and because YOLO is bigger than all the other ones. So we can see that it's working, okay? So that's how you implement a binary search tree in Python. And if you found this video helpful, give it a like and subscribe, and I'll see you in the next one.